All right, chapter 1 review. There's a few different ways to do this, but before we do anything, we must notice that we do not have our variables lined up. So this won't work right now. So I'm going to rewrite it. A plus 2b equal to 3, and then 6a plus 12b equal to 18. All right. Now, I can cancel the a's with negative 6a or negative 12b. Doesn't matter. So I'm going to multiply this by negative 6. What it's going to give me, I'm going to write it right underneath here, is negative 6a minus 12b equals negative 18. When I add these, everything cancels. I end up with 0 equals 0. And when we get a true statement like that, 0 equals 0, 5 equals 5, doesn't matter. That is infinite solutions. It's the same line. Now, we could have also done a matrix on this. So we can go into our calculator, go to matrix, edit. Okay, we have 2 rows and 3 columns. So it's a 2 by 3. And we have 1, 2, 3, and 6, 12, 18. And then we quit. We come back into matrix, go over to math, go up to rough, and then tell it again to look at matrix A. And remember, when you get 3 zeros on the bottom like that, that means infinite solutions. All right, number 2. Mr. Wheeler collects old bicycles and tricycles. So I want to use B for bicycles and T for tricycles. All right. In his collection, there are 50 wheels. Now, that is a value number because there's different wheels on different bikes. But seats, that's the number of bikes there are. So that means B plus C equals 23. There are 50 wheels. There are 2 on each bike and 3 on each tricycle. And there you have it. Now again, this one you could do 3 different ways. You could solve the top one for either B or C, plug it in and substitute. You can multiply by negative 2 or negative 3 to cancel. I'm going to do negative 2. I always go with the smaller one. So negative 2b minus 2c equals negative 46. When I add those, I get 1c equals 4. That means there are 4 tricycles. And 23 minus 4 is 19, so that's 19 bicycles. And again, we could do that as a matrix. I'm not going to run through it, but we put 1, 1, 23, and 2, 3, 50. And when we run that through, we will get our identity matrix and then 419 on the right side. You just got to remember what the letters stand for. And that's why we label them so we know what we're dealing with. Number 3, classic problem. I have nickels and dimes. So dimes is 0.10 or just 0.1, and nickels, be careful, is 0.05, not 0.5. So in this one, we don't know how many we have, but we know we have 7 more dimes and nickels. So dimes is nickels plus 7. Okay, so we're going to use D for dimes and N for nickels in this case. Again, you can use XY if you want to. And then we're going to put in order. So that's going to be D minus N. Well, hold on. Let's just do the other one first. So 0.05 n plus 0.10d equals 4, because we have $4. Now this one is one where substitution is pretty easy. We could just plug this in right there and calculate it out, which would give us 0.05 n plus 0.10 parentheses n plus 7 equals 4. Then we multiply, we get 0.05 n plus 0.10, whoops, extra 1 in there, n plus 7 times 0.1 is 0.7 equals 4. So what we have is 0.05 plus 0.10 is 0.15 n. I'm going to minus the 0.7 at the same time. And $4 minus 70 cents is $3.30. And when I do 3.3 divided by 0.15, I get 22. So n is 22. So that's 22 nickels. If I plug that in here and add 7, that's 29 dimes. Now, if I wanted to, I could have also moved the n over, and I would have had negative n plus d equals 7, and then multiply by 0.05 or negative 0.10. I could have canceled and done elimination. Doesn't matter. And I could have also set that up and put it into a matrix. So you have choices. All right, number 4, notice not in order. My x's are lined up, but my y's and numbers are not. So in this one, I need to move this over here and this over here. Oh, sorry, no, wait. That one is right. Never mind. That one's okay. So 2x minus 4y equals 32. It's this one that I need to move the y over. So 10x minus 20y equals 65. All right? Now again, I can multiply by negative 5 to cancel the 10s. I can multiply by negative, well, 5 will actually end up canceling the y's too. So let's see what ends up happening. Whoops, did not mean to do that. I only meant to do it on one of them. And that's going to give me negative 10x plus 20y equals 5 times 10. That shouldn't be there. So 5 times 2 is 10. 5 times 3 is 15. 16, negative 160. But what happens here is those cancel out, and I end up getting 0 equals, doesn't really matter what the number is, but it's going to be negative 95. This is a false statement, which means no solution. And if we would have put this into a matrix and solved this, we would have gotten this. So as a reminder, when you get 0, 0, 1 on the bottom, that is no solution. If you get 0, 0, 0 on the bottom, it's infinite solutions. So for example, this one up here, number 1, would have looked like this. 1, 2, 3, 0, 0, 0. If you did it by matrices. Okay. All right. So remember, we have a number here to multiply. So we need to multiply by all these first. So that's going to give me 4 times 2a is 8a plus 4b. 1/5 times 4 is 4/5 c. And 4 times 12 is 48. That's my new first matrix. I'm going to cross it out so I don't accidentally use it. If you need to rewrite these two here, you can do that. If you can bounce from here to here to here and write them, you're good to go. Doesn't really matter as long as you show your work. So the first one is going to be 8a plus 6 equals 30. So we're going to subtract 6, get 8a equals 24, divide by 8, a is 3. And then b, we have 4b minus 7b equals 33. So that's going to be negative 3b equals 33. Divided by negative 3. B is equal to negative 11. Okay. I'll do C now. 4/5 C minus 8, so equals 32. Add 8. I get 4/5 C equals 40. If I multiply 4 times 40 and divide by 5, or easier, divide 5 into 40 first and get 8 times 4 is 32. So C is 32. And last but not least, D. Actually, there's no D. Never mind. We're done. Because notice, this is 10 here, and this is a 58. And 48 plus 10 equals 58. So A, B, and C. Those are my answers. All right, number 6. A vendor made $565 selling 250 ice cream cones. Single scoop costs $2, double costs $2.50. So I'm going to do single scoop and double scoop. So we have S plus D equals 250. $2 for a single plus $2.50 for a double. That's a bargain. 565. So I'm going to multiply this by negative 2, which is going to give me negative 2S minus 2D equals negative 500. When I add those, my S's cancel. $2.50 minus $2 is 0.5 D equals 65. And when I divide 65 by 0.5, it's actually the same as multiplying by 2. Doubles is 130. If I subtract that from 250, singles is 120. All right, I just worked this whole problem through and realized there is an error because this does not exactly match the one in your packet. So first off, I'm going to just try to fix this up. This should be negative 38. And 3x plus 10y equals, this is a 50 on your paper. This is 47 on your paper. And this is 11. So now I'm going to rewrite all these in order to match yours and put them in order. So kind of fix everything up at one time. So it doesn't matter which way you want to go. Down here we have X, Y, Z, W, but some people want to do alphabetical order. So I'll put them in alphabetical order. This needs to go over there. And the negative 38 needs to come this way. So it's going to be 4W plus 5X plus 7Y plus 2Z, those all stay the same, equals positive 38. And then here, again, the W has to come over, so that's going to be 1W. The 3X stays positive. The 10Y stays positive. The negative 5Z is going to move over and become plus 5Z. And the 50 stays positive. And this one, all I need to do is move this to the front. And don't make it opposite because it's already on the right side. I'm just moving it to the front. So 8W, 9X, 6Y, 1Z, And again, 47 to match your paper. And here all I'm going to do is move the W to the front. And put the 11 on the other side to switch it around. Okay, it's not negative 11 because all I did was move it. All that still equals 11. So what's my augmented matrix? My augmented matrix is 4, 5, 7, 2, 38. And 1, 3, 10, 5, 50. And 8, 9, 6, 1, 47. And 1, 1, 1, 1, 11. Now, my calculator is going to already be set up for this is a 4 by 5, 4 rows, 5 columns, because I've already done this problem twice and it's been wrong both times. So let's go back in and edit this properly this time. 4 by 5. So 4 is right, 5 is right, 7, 2. I have to change this to 38. 1 is right, 3 is right, 10 is right, 5 is right. I need to change this to 50. 8, 9, 6, 1, and this needs to be 47. And then 1, 1, 1, 1, and that needs to be 11. I already fixed that. So now I quit, come back to the matrix, go over to math, up to ref, double R, not regular R, and hit enter, and tell it to look in A. And there's my answer. Okay, in order W, X, Y, Z, 1, 3, 1, 6. So 1, 3, 1, 6 as a point, and otherwise it's W equals 1, X equals 3, Y equals 1, Z equals 6. All right, that one's finally done. Oh, 8, 9. Okay, so here we have a 2 by 3, and here we have a 3 by 1. We check the inside. It's good to go. I know my final answer should be a 2 by 1, and I'm just going to go into my calculator. So second matrix, over to edit. I'm putting in a 2 by 3. So 1, 2, 3, 4, 5, 6. Quit. Back into my matrix. Go to edit. Down to B, choose this time, and put in a 3 by 1. And that's, remember, use the gray negative key, negative 43, 98, and negative 54. Quit. And now I'm going to say matrix. Choose A times, and remember, order matters. A times B is different than B times A. Second matrix, B. And there's my answer, negative 9, negative 6. And that is a 2 by 1. So I know I did it right. All right, number 9. Number 9 is a 3 by 3. And this one is a 2 by 3. We look at the inside, and that is not possible. Those numbers need to match. Number 10, a pound of assorted nuts costs $3. A pound of M&Ms is $4. How much of each should you combine to make 10 pounds of trail mix? They cost $3.25 a pound. So I have nuts N, M&Ms M. So nuts plus M&Ms, we want 10 pounds total. Nuts cost $3 a pound. M&Ms are $4 a pound. And remember, this one's tricky. we need to do 3.25 times 10, or 3250. I'm just going to use a matrix on this, go nice and quick. So, second matrix, edit a 2 by 3. We have 1, 1, 10, and 3, 4, 32.5. We quit, come back in, go to math, go up to B, enter, tell it to look in A, and we get 7.5 and 2.5. So 7.5 pounds of nuts and 2.5 pounds of M&Ms. And that is it.